Hello, guys, welcome to Success. So, today we are officially starting with our lectures, and as planned, we'll be going as per the NCRT order. So, first, we are starting with chemical reactions and equations. Unlike other channels, we are not going to be doing long lectures. We are actually planning to do short videos, which will be actually useful for your revisions before the exams. So, we are trying to end every chapters before 30 minutes. So, what to wait? Let's just get into the chapter. So the chapter's name is Chemical Reactions and Equations. So what is actually a chemical reaction? Chemical reaction is a change which involves reactants which react together to get a new product. So there will be reactants which react together to get a new product. So how can we identify if a chemical change has taken place? So we can actually use four different techniques to understand if a chemical reaction has already taken place. So the first, as given, it is a change in state. When we keep a ice cube in the room temperature, we'll be able to see that it melts. That is a change in state. That is a chemical reaction. Now, next is change in color. In chemical reactions, we can observe change in color. These are not about every reactions, but these are one of the changes that can be observed. It can be either change in state or change in color. Any one of these will be surely visible. Now, next is evolution of gas. In some reactions, we can see that there is an evolution of gas. When we heat water, we can see water vapor going. That is an evolution of a gas, and a chemical reaction has taken place. So, what is the reactant over there? Water was a reactant. When we heat it, water vapor is given out, which is a different state, that is solid, liquid and gas. We have converted a liquid to a gas. Now we can see a change in temperature. This is a very important topic, change in temperature. There can be two types of temperature change, that is endothermic or exothermic. What is this actually? Endothermic means something which absorbs heat. You can remember it like endothermic, that is entry. Exothermic, that means exit. So endothermic means when the reactants absorb heat energy, so its temperature will rise. Exothermic, they release energy. They can be released in form of heat, energy, electricity, etc. But the energy absorbed will be in the form of heat only. For example, endothermic, when you cook an omelette, heat is absorbed by the egg, right? So that is an endothermic process. Exothermic is anything which releases heat during a chemical reaction. So you have studied till this. Wow. Now let's go to the word equation and chemical equation. So a chemical reactions can be expressed in two forms. That is word equation and chemical equation. What is a word equation? A word equation is something that if a reaction has happened, that is hydrogen plus oxygen is equal to water. When you express as the name of the elements, that is hydrogen plus oxygen is equal to water, when you express it in form of words, it is actually known as word equation. But more convenient way is a chemical equation. We express it in form of symbols. That is H plus O2 gives H2O, which is more convenient and which is more widely used in the field of chemistry and other subjects too. So chemical equations can be actually divided into two: skeletal equation and balanced equation. Skeletal equation is an equation which is not balanced. That is, there is a you have learned a law in class 9, that is law of conservation of mass. That is, mass can neither be created nor be destroyed, but it can only be shifted from one form to other. So, whenever you write a chemical equation, you should please note that the equation is balanced, otherwise you will surely lose marks. So make sure whenever you are writing the exam that all the equations you are writing is balanced. So skeletal equation is an equation which is yet to be balanced, and balanced chemical equation is an equation which is already balanced. So I would be preparing a separate video for balanced chemical equation, as it needs a lot of practice to be more easy with that. Like first when you're doing it, you will feel very hard, but trust me, practice makes everything better. So here you can see an example of that. What is that? CH4 plus 2O2 gives CO2 plus 2H2. This O2, the before O2, you can see a 2. How did it come? So, first, there was only one carbon, four hydrogen, and two oxygen. But in the reactant side, you can see there was one carbon, there was three oxygen, that is O2 plus H2O. So there is three oxygen actually and two hydrogen. So in order to balance it, we have put the two before the oxygen in the reactant side and two before the water in the reactant product side. So that's how you balance an equation, and I will be surely preparing a video separate, like based on balancing a chemical equation. Now let's move to the next topic. So, what are the types of reaction? First, we are going to learn is combination reaction. Combination reaction is the easiest reaction to learn. What is that? A plus B is equal to AB. It would be better if you could learn these variables. A plus B is equal to AB. So, what does it mean? When two or more other reactants combine to form a single product, there can be so many elements in the reactant side, but in product there will be only a single product, that is a combination reaction where reactants combine to form a single product. Examples are calcium oxide plus water is equal to calcium hydroxide, as well as carbon plus oxygen is equal to carbon dioxide, which is the most famous or which will be familiar to you, that is carbon plus oxygen is equal to carbon dioxide. And for every reactions, please make sure that you're learning an example. So whenever there is a question asked in exam, you should write an example of the equation in the simplified, that is in the balanced form itself. And if you can mention the state of the element, it would be the best, so that there is no chance of you losing marks. So the next one is decomposition reaction. What is decomposition reaction? As you can see here, a single reactant split to form numerous product. So in the reactant side, there would be only one reactant, but in the product side, there would be two or more elements. So, decomposition reaction can be of three types, that is, thermal decomposition, photolysis, and electrolysis. What is this? Thermal decomposition, decomposition with the help of heat involved in it. When we are applying heat to a product so that it gets split into various products, it is known as thermal decomposition. Example, iron sulfate, when we split it with the help of heat, it becomes Fe2O3 plus SO2 plus SO3. And there's a color change in this. So you have to note, that's a homework actually. You should note every color change. That is, actually, iron sulfate is in the form of FeSO4.7H2. It is in the combined form with water, that is water of crystallization. What is water of crystallization? Water of crystallization can be defined as a number of water molecules present in the element. So when it is in the water, water of crystallization is accompanied with FeSO4. It is different color. When we heat it, it becomes FeSO4 plus 7H2O. Then we heat it again, and then we get this product, that is Fe2O3 plus SO2 plus SO3. This is a very important example. It can be asked for your school exams as well as your board exams. So make sure that you are learning this example. Now, next is photolysis. What is photolysis? Photolysis is when the nature, that is, the sunlight, is used for this decomposition. The best examples are AgCl and AgBr. Both these examples are very important because these are used in black and white photography. So a question can be asked: which are the form of decomposition that are actually used in black and white photography? You should be able to write AgCl as well as AgBr, that is silver chloride and silver bromide. You should learn the examples of this, and that what is its use? It is used in black and white photography. Okay, next one, electrolysis. Electrolysis is splitting waste with the help of electricity. We pass electricity through water and we get 2H2 and 1O2. So, what is important in this? You should know that the hydrogen to oxygen ratio is always 2 is to 1. That is the important thing in the electrolysis section. Now let's jump to the next section, which is displacement reaction. So what is actually a displacement reaction? As you can see here, if A is an element and CD is another element, after the reaction, we will get AC plus D. we can see that the anion has changed. What is an anion? Anion is negatively charged, cation is positively charged. So we can see that here the anions has changed. So that is a displacement reaction. We can like learn better when we learn with examples. So here Fe plus CuSO4 is equal to FeSO4 plus Cu. Here we can see that the Fe has converted to SO4, that is FeSO4, and Cu is left alone. This is actually based on the reactivity series. And if we check the reverse of this reaction, that is Cu plus FeSO4, there would be no reaction. Why is it? It's because of the reactivity series. Always, the more reactive elements will replace the less reactive metals. So you should learn this by heart. So I have a trick over here, that is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. If you remember this acronym, you will be able to easily recollect the reactivity series. So make sure you are learning this, because without this, you won't be able to learn the displacement as well as double displacement, which we are going to discuss now. Double displacement reaction. So what is actually a double displacement reaction? Here we can know that only one element was here. But here there would be two. That is AB plus CD is equal to AC plus BD. Here both the anions have exchanged. Here we said that anions have transferred. But here the anions have exchanged themselves. That is AB plus CD is equal to AC plus BD. This is a very, very, very important example. If you don't learn this, you will be in trouble. This with the balanced equation. Okay, I'll try say you a trick to balance this, to remember the balancing of this equation alone. That is, just I hope you all are 2k kids. So just remember that before the k there should be 2. So it is 2k. PP doesn't have anything to do with the balancing equation. Before the k there should be 2. 2k kids, 2k. So that's an easy way to remember it. So double displacement reaction, make sure that you are learning this example. So double displacement is exchange of anions and displacement reaction is transfer of anions. This is also based on the reactivity series. Now we are going to a last type of reaction, that is a redox reaction. What is a redox reaction? Redox reaction is a combination of oxidation as well as reduction. What is oxidation? Oxidation is a gain of oxygen and reduction is loss of oxygen. Okay. Reduction can also mean gain of electron and oxidation can also mean loss of electron. So let me just summarize. Oxidation can be either gain of oxygen or loss of electron, and reduction can be either loss of oxygen or gain of electron. You will learn it better with an example. See here. CuO plus H2. When we are applying heat, it becomes Cu plus H2O. Here we are able to see that from the CuO, the O is escaped or the O is transferred to H2. So CuO becomes Cu, that is a loss of oxygen, which is actually reduction. And H2, it is actually oxidized to water, means H2 gains oxygen to become water. So gain of oxygen is oxidation and loss of oxygen is reduction. By this we come to the end of types of reaction and going to the last and final topic, that is corrosion and rancidity. So what is corrosion? Corrosion is a process by which a metal is attacked by external factors like moisture. Metals which are of high reactivity. I told you reactivity series is very important for this chapter. So highly reactive metals react with moisture, air and other air pollutants which actually degrades the metal. For example, iron particles. Iron particles get coated with a reddish brown substance when left open for some times. This is called rusting of iron. So when you can see near the beaches, if you notice the iron rails, you can see that a brown coating is developed on it. What is it? It is a rust of iron due to excessive moisture near the beach. So this rusting will continue till the whole metal is destroyed. So the rusting is so we can prevent rusting through various methods, that is painting, greasing, galvanization, and many ways are there to prevent rusting. But as iron is a high reactive metal, It easily gets degraded by moisture, and this is known as rusting. This is an important topic. And the next one is rancidity. What is rancidity? Oxidized fats and oils produce smell and taste that is known as rancidity. That is not chance, actually, it is a change. So, taste change. This is known as rancidity. When fatty or oily food get in contact with oxygen, that is, oxidized fat means what? Fat or oil which come in contact with oxygen. When you keep let's say jam open for a lot of time, it will get bad, like we it is not suitable for eating. That is because the oxygen enters it, and the fats are actually, it produces a smell, and a foul smell, so we won't be able to eat it. So that is known as rancidity. That is, oxidized fats and oil produce smell, and a taste change, that is known as rancidity. So, what are the ways to prevent rancidity? That is, using gases in packaging. Where the lace packets, we all complain that the lace packets are not keeping enough chips and it is just full of air. But it's actually to save the lace. That is, the chips packets are flushed with nitrogen gas to protect it from getting degraded by this rancidity. Using antioxidants are the substances used to prevent rancidity. Refrigeration, keeping it in refrigerator can help. Then vacuum packing so that it doesn't get in contact with the oxygen. Using oxygen scavengers, using airtight containers and storing it in a dark place and all can help preventing rancidity. By this, we come to the end of the chapter. I hope you liked it and it is very useful for your exam preparations. I have attached the PDF of this flow chart in the description box. Please make sure that you are using it for your exams. We have finished our chapter in just this one flow chart. So, guessing this was very useful for you. And till I come with the next video, bye bye. Make sure you like, share, and subscribe. And if you have any doubts regarding the lectures, please let me know in the comments. Bye bye.